guys, a few of you have asked about a natter about diverter valves. Sorry if this is a bit basic for some of you guys, but obviously we're not all on a par when it comes to knowledge. One thing I will say, guys, is as gas engineers, there's one thing that we can't believe in, and that's ghosts. If we believe in ghosts, then it can knock us off track. So you know, there's things that is right and things that is wrong, and when you're in front of a boiler, you've got to look at everything in sequence. Okay, we'll just address 3 different types of diverter valves this morning, and obviously I don't want to bore you to death with too long a video, so I'll go through. And just remember, guys, I'm doing this off cuff. This is not, you know, there's no editing goes on here. This is off the cuff, so if there's little bits and pieces that I say which are just not quite correct, then I apologise. Right, we'll start off in the old days, shall we? And here we've got the old Giannoni diverter valve. Okay, now on the end of the diverter valve we have the plunger. The plunger, here we have a micro switch. Okay, this could be a double micro switch or a single micro switch depending on the type of boiler it's fitted to. How does this work? Here we've got the cold mains, and here we've got the cold mains into the plate, or going even further back in time down to the double pass, going up to the double pass heat exchanger. Here we've got the butyl rubber diaphragm, and as we move on to the body of the valve, here we've got the central heating flow, here we've got the central heating return, and here we've got the bypass. And the bypass is the bypass that supplies the plate heat exchanger. So basically, when Mrs. Smith opens the tap, the plunger moves, the diaphragm moves, the plunger moves, it hits the micro switch. When it hits the micro switch, all that's doing, guys, is moving it from a lower burner pressure central heating to an higher burner pressure domestic hot water. But as it does that, what it does at this part of the valve, it closes down the heating section on domestic hot water there and opens up the bypass here to supply the plate. Okay, now failures on this valve, as we know, one, we could have a pinprick in the butyl rubber diaphragm, so the customer says they have to open the hot tap maximum for it to fire. That's a pinprick. We can have a situation where the plunger's not moving at all, then there's a tear in that diaphragm. Okay, we can have a situation where the water's not performing. As I say, there's no ghosts. If you've got the correct flow rate through the hot tap as matched with MI, and if you've got the correct burner pressures, then the hot water's got to get warm. If it's not, then you need to investigate why. So if we grab this central heating flow underneath the boiler, if that starts to get warm, then this valve is passing. And basically all it is some debris stuck in there. I've seen it on brand new boilers many years ago where there were a blob of solder just stuck in that disc there, so it was allowing 50% of the water to go to the plate and the other 50% to beetle off around the heating. You know, so as I say, it's simple. You can also have a situation where you've set the flow rate, you've set the burner pressures, you've grabbed the central heating flow, and it's still not getting warm. Well, in that case, guys, if the burner's staying on, then simple. Isolate the cold main underneath the boiler, make sure the hot tap stops running. If the hot tap continues to dribble, then something is passing. It could be a shower valve, it could be a hot and cold fill water washing machine, it could be a mixer tap that's passing. Simple, okay? So that's basically the old Giannoni diverter valve. Now, there's one thing before I move on from this. You think this is old hat. Well, I'm sorry guys, I disagree. Because with modern valves, which we're going to look at shortly, okay, especially when you've got a plastic block, you guys are fitting mini expansion vessels and you're fitting anti-shock valves on the cold main. Well, there is an argument to say we're going backwards, not forwards, because this valve, okay, there's your anti-shock, okay, and there's your mini expansion vessel. So it was built into this valve, so it wasn't necessary, okay. So power of marketing is a very clever thing, but here we go. Right, let's move on to, this is a more up-to-date block that you're used to working on, and here we've got the electro motor for the diverter valve, and here on the cold main we have the cartridge, and on that cartridge we have a flow sensor. So when the hot tap is open, this flow sensor illuminates, okay, and that tells you that basically there is power to the electromotor and it's energized. Now how does that come about? Well, if I unscrew that, okay, and if I take this apart, there's a filter, which is always worth checking if you've got a poor flow rate from the hot tap. Here we've got a plastic missile, and on the end of it we've got a magnet, okay. So as the cold main hits that, it spins, it drops, and as that magnet passes over the magnetic sensor, it illuminates and basically allows power to the valve. So no light, then basically this magnet for some reason is not being pushed. It could be debris. Very common as well with this type of mechanism, that light can stay on all the time. If that light's staying on all the time, it's as simple as this is stuck, guys. It could be debris, clean it or change the cartridge, okay? Now, once we're sure that we've got the red light and we've got power to the diverter valve, the actual diverter valve mechanism, from this being the diverter valve many years ago, this is now the diverter valve, okay? And how this operates on this particular valve, when the motor closes, bump. This seal here closes the central heating return, okay? So stops the central heating, the space heating. Here with another seal, and that seal opens to supply the plate-to-plate heat exchanger. And as it retracts, it closes the plate and also then opens up the space heating to allow the central heating to operate. Now, same as the old valve, you can still get debris around here so it can still pass. You can get debris here so it closes and it still passes around the plate. It's so, you know, it's the same. One thing that this did fall down on a couple of years ago is you've had a situation where these leak, okay? Well, if you look at this, this is one that's been changed. There's a ridge of debris, so there's high debris in the system. And if you look at that plastic shroud there, guys, what was happening, that ridge of debris, as this was moving up and down, that ridge of debris was knocking into the O-ring here and consequently causing a leak. Now, simple solutions are always the easiest. What we did with the manufacturer of the valve, we asked them to increase the length of the shroud. So by increasing the length of the shroud, it stops the valve hitting the O-ring. So hopefully that problem's being addressed. Okay. Now we have another type of valve, which is this one here, okay? And this one works via a turbine, okay? So basically the cold main hits this turbine, the turbine spins, and basically then the flow sensor picks that up and allows it to divert from central heating to hot water. If I had to pick a favourite, guys, this one is my favourite, okay? But keep that quiet, okay? So, basically that's just a run round of diverter valves. We'll deal with hot water faults in more detail shortly on another video. So, once again, guys, thanks for your time. Cheers.